Thank you very much, and thanks for the opportunity to speak here. Good morning, everybody. As the title suggests, I would like to share with you our approach, how we bring people from basically mainframes to the cloud, and doing this with as less disruption as possible. So minimize risk, cost, and timeframes. Most of our customers, when we talk to them, I have to click here just a moment. Thank you. They're very busy, or they get a lot of demand, and as we just also saw with the previous speakers, to introduce DevOps, more agile approaches to help their customers with with digital transformation, to introduce microservices and to move to the cloud. At the same time, however, they're often there's a number of obstacles. There's still high cost of what it's called the legacy environment. There's a lot of obstacles also with agility. And very, very important these days, we also notice when talking to clients that the skills of these legacy environments, the skills to deploy that, to operate them, the skills to do additional development, and these skills are evaporating. There's a whole generation of people retiring, and sometimes the platform is threatened to disappear entirely. Now that's what you're supposed to do. To the left, that's things that you might be facing. Here to the right, now we have a number of customers that took action, and this is a list. What these people did. They took a drastic decision, and they moved away from mainframes, basically ZOS, to another environment. Let's put it that way. There's sometimes exceptions also, in the sense that what people consider a legacy environment and consider a new environment. So the first line here, that's Société Générale in Paris, you see they move out of natural database, but they stayed on mainframe. So it doesn't always have to be away from mainframe. But as you see here also, most of the customers that we've done lately, and that we've worked with lately, have gone to an x86 platform that was either Windows-based or Linux-based. And what you might notice also is that many of those took the opportunity also to move out of their legacy language, which is sometimes, of course, natural or ADS in the sense of in the case of IDMS, but also COBOL. So some people decide to stick to COBOL, and some people decide to move out of COBOL to an object-oriented language, such as then Java or C#. The way you can do this, of course, and here I have an overview of what the possibilities are if you have a legacy issue and you want to do something about it. This is the Gartner taxonomy. Of course, you can retire your application, or you can retain it as is, but that's not really doing something about it, is it? So you can reuse what you have, of course, and package it and offer it as a service-oriented architecture. But that's, of course, a temporary fix and doesn't solve many of the issues that we just talked about, like, for example, the skills issues still will be there. You can rehost. That it means you just take what you have and put it on another platform without even recompiling. That is possible these days. There are solutions, but again, it's quite a temporary fix. You can re-platform. That means you recompile. So your enterprise COBOL, for example, becomes Micro Focus or Fujitsu COBOL or something. And then you can do what we offer here, the Anabex approach. You can refactor or re-architect. That means we convert all the artifacts into natively the new environment, or natively into the new environment. And that can still be COBOL, as you just saw in a number of these cases that we have, but often that is Java or that is C#. So there is no immolation. You just move from your mainframe without immolation natively into the cloud. Other approaches are to rebuild what you have based on the same specs, or to replace. That means you have different specs and you redesign everything from scratch and entirely. Of course, we all know these approaches here in the right corner here. They are high risk. They take a long time, and we've also worked with a number of customers that tried this, and then after a couple of years stopped their efforts and came back to a more what we would call a realistic approach. So this is what we try to accomplish with our customers: refactor and re-architect. That means we bring them basically into the new world. So we bring the legacy applications to native technologies, to the cloud, while remaining functionally equivalent. So as in this, at the start, your application will behave exactly the same. After the project is finished, can be phase one in the modernization journey, in the modernization program. You get out of your mainframe, you get out of your legacy environment, but at that moment, it's still functionally equivalent. What's very important is automation. We automate all the steps necessary. That means not only the conversion, which is obvious, of course, the conversion of source code, data structures, but also the testing. By converting, we do inherent modernization. That means, for example, Adabas does not know the concept of a date or timestamp. If you go to a relational database, you introduce a real date or time field. Field to this. Then, of course, you can also take that opportunity to, for example, split your tables and normalize or denormalize as you want. And of course, what's very important also, the automation of the testing, and we'll come back to that. If you do this, you accomplish a number of things. First of all, it is a very technical project at that moment. It's driven by IT. Remember, we are functionally equivalent. That means the users will, at the end of the project, don't see a real difference at that stage. So the business involvement is kept to a minimum. It's typically the user acceptance testing. Means also by the fact that we automate the testing, that the amounts of testing is extremely limited compared to other approaches. Means the risk is well managed, and acceptance, because the acceptance is pretty straightforward, because the main acceptance criterion is this application still behaving and doing the same as it did before? We have other acceptance criteria also. That is the maintenance of the application acceptable? Can the developers continue to maintain the code at least as well as before? And mostly it is even better because they have now a more modern environment. And the third acceptance criteria is the performance. Is the performance also the same or better than before? As a result, of course, you save money because you go from a more expensive environment to a cheaper environment, if I may call it that way. And that money you can invest in further modernization, which then is, as I said already, which are follow-on projects after you're finished with this one. This is the support that we offer for this kind of from and to environments. And so this is the most common mainframe architectures, let's say, with plain ZOS and CICS. The blue parts, we do not, want to reinvent the water. We sometimes have very good partners that have, for example, a PL1 to Java or an EGL to Java solution that is then built into our total solution. The target environment is the most common databases. Open source is coming up more and more. In the past, people went more to the traditional databases. Now there's a lot of demand for open source databases or cloud-based relational databases. The languages we spoke about. The environment is either an x86-based environment on-prem or off-prem in the public cloud. And as I said, sometimes people still modernize also on ZOS. That happens also. Now, what is important? If you want to do this, what do you need? If you want to minimize your risk and you want to be sure that you're within a certain time, within a certain budget, are out of your legacy, well, the first thing you need is automation. So you need basically 4 types of tools. The first one is a tool to convert or transform your code. It can be from Enterprise COBOL to, for example, Micro Focus or Fujitsu COBOL, but it can also be from Natural to Java, from Natural to COBOL. It can be from COBOL to Java, COBOL to C#, whatever. The second is, of course, the data conversion, where you convert your data either from your existing relational database, but also from vSAN, from Adabas, from IDMS to your relational database. Then you need testing. You need to do the online testing to test the behavior of the online applications. Can be still screen-based, can be with a GUI front end, but you need to test that they behave exactly the same as before. And that needs to be automated in order to save time, to save money, but also to manage your risk. And last but not least, you need to also be able to test whether your data in your new environment, after running logic, whether the data are still the same as they are on your mainframe. And for that, there is a tool we call data mesh. Some of our customers, and that's maybe important also to talk about for a moment, some of our customers are quite reluctant with the change management. If you have, you're a big bank and you have a couple of hundred COBOL developers, you might want to go a little bit slower in, moving from COBOL to Java, for example, from COBOL to C#, because the change management and, replacing or making sure that all these people have the skills it's a big task. For that, we have also introduced COBOL Bridge, which is a tool that allows certain teams, for example, to continue to maintain their code in COBOL, while underlying we have already the converted, the generated Java that get executed. While maybe other teams already work directly in the Java without COBOL Bridge, basically. So they just use the Java in their IDE that they're used to do, that they used to work with for Java or C# for that matter. So one important aspect is automation. The second important aspect is a methodology. A methodology that makes optimal use of that automation that you have. And that methodology that we have introduced goes through a number of phases, where after we have assessed everything and know what we want, exactly what the reference environment is, we start converting. And every dot here, typically, on this spiral here that you see, every dot is typically, let me use my laser point, every dot here is typically a place in time where we take a new picture, a new snapshot of what is then current in production. So maybe the project takes a year. Well, at certain times, at certain intervals, we get in sync with what's then in production. And we start working on that. And first of all, we make sure we have syntactic correctness. That means that, with our tools, we make sure that, for example, the COBOL now converted or transformed to Java, that it, compiles 100% correct. And the spiral means the way we work is we convert the code, we test with our tools, convert with our tools, test with our tools. And if there are still differences, we tune the tools until we get it right. So we do it over and over again, many, many times until we get it right. And we say, okay, now everything is 100% correct in terms of syntactic correctness. We have, we've done many, many projects. We can almost after just a few days, we can always predict already when we will reach the status based on previous experience. And then the second phase is semantic correctness. So we continue really with the same cycle until the inputs and outputs are the same in your legacy environment and the new environment, based again on the tools for conversion and the tools for testing. So this whole process is automated. Then we go to system integration testing, user acceptance testing. That means also at the very, very end, because we automate everything, we keep current with what's in production. That means at the very, very end, we only need the code freeze also. And then we go live with the application. So the combination of automation and tools on one hand, and the methodology on the other hand, is the key to make sure that we minimize the risk, minimize the cost, and have a very, very predictable project. Maybe a quick view on some of the tools. Codeturn here is a tool for code conversion, and you see here some of the options that we have. Also assembler, by the way. Many mainframes still have a assembler. Sometimes it's a technical assembler, but in many cases it's also functional assembler that can be automated or automatically converted also to Java or C#. The aim is, of course, 100% automated code transformation, very important. In reality, we reach 4 nines. In most all of our projects, it's 99.99. There's always one or the other acceptance situation, change interface, something that a little bit has to be done manually. But 99.99 is not bad if you talk about that. Just for an example, 10 million lines of code. That's good. The advantage, I think, are clear, consistent, fast, repeatable. You can do it over again because we do it over and over again, remember. And the tools are, very, very customizable. especially if you go from a procedure language like COBOL or Natural to an object-oriented language. There's a lot of options you have how you want this this Java or the C# that comes out of it, how you want it to look. Also, the Codeturn is also used to do the analysis before we start. This is a real life picture, so of a customer that had, I think the green was Natural, this here the more cyan is COBOL programs, the black were assembler programs, and the reds were missing. So things were called that were not there. That was the initial intake of the application. You can zoom in, we can export this to an Excel, and of course you can start working on it. When we start a project, what's extremely important, we do this analysis and we bring everything in a picture before we start, and we know every statement that is used, for example, and how many times it's used, where it's used, so that we know, can our tools cope with it, yes or no? Have we seen this before? This ignore statement, yes we have, yes we know we can convert it to Java, or not. And of course, for example, also JCL, there's most often a big and important batch component in the application. The JCL calls all these utilities. Well, we have to make sure also, so utility by utility, we will do a scan and say, okay, this is the usage. And we'll establish also, do we have a replacement in this x86 world for it, yes or no? So this is just an example, but that's the start of the project, is the full analysis before we do our first conversion. And of course, we have to work with the customer to make sure that also these red little boxes are in another color at the end of the day before we start. Or, well, we can start already, but before we go into production, for sure, we need to make sure that we have all the source codes and that all the sources that are missing are available for conversion. So that's Codeturn. Dataturn is what basically the name suggests. It's a full support for conversion of data. It even generates, when needed, the JCL to unload the data on the mainframe, and then of course to create the tables and with triggers, everything is there for all the data stores that you come across typically on the mainframe environment. This is the conversion. We also said it's extremely important that you do testing, that you automate the testing, and one of our tools for that is TestMatch. What we basically do, we have on the left our mainframe environment, let's say Natural with Adabas and maybe some vSAN, also COBOL, and then we go to, I don't know, an Oracle Java environment on a Linux, or it can be C# and SQL Server on Windows or whatever, on-prem, off-prem. But basically what we will ask the customer is to execute transactions on the mainframe. Can be in a test environment, can even be in a production environment, and we'll record those. We can record those on the PC here, that's your PC where you test, or you can switch on recording what's called fit and trace, which is available in every mainframe, and then you have a test set that you get for free. So you ask customers just execute transactions, can be even an hour of production. You switch on your tracing and you import it, you have a base scenario. The tool then will do basically two things that are left to do. It will launch the replay of the same transactions, but then against the new environment. So you will execute, for example, your Java against your Oracle database and put that basically in the repository of the tool also. And then the second thing the tool does is basically comparing the original scenario with the tested scenario and see whether there are any differences between the inputs and outputs of the transactions. I've just one screenshot here just to show you also the principle and the methodology. So at this moment, this was a real life example quite a while ago. You see it's in 2013, but the approach is still the same. You see this particular transaction got executed 27 times correct in our test set, but 6 times it was incorrect. And this one, 25 times correct, and once it was skipped. The test match will skip a transaction when the transaction is invoked after a transaction error. On the left here, you see the base scenario. That was the recording, and then all the tests against that base scenario. And remember, we have this principle: we convert, we test, and we tune. And if you look at here, for example, on the 18th of April, we did the first test, and then we did a second, third, a fourth, a fifth, all on the same day. Or people have been converting, testing, tuning until they got it right. Well, they didn't get it right on the 18th, so they continued on the 19th and so forth, but you get the principle. And then last but not least, there is this data match, where we compare much according to the same principle data stores. So typically this is used to test the results of batch jobs. People have long batch changes during the night typically, and we run these batch changes in both environments. So we do it in the production, and we also run the same in our test environment on our x86 platform, for example. And then we will look at the data stores before and after running those batch jobs, and we will inspect with the tool whether they are the same. They're supposed to be the same, right? Otherwise, the conversion did not go right. There's a lot of configuration options here also, excuse me, to dive into certain columns, rows, and so forth and so on. Because these batch jobs is typically, they manipulate millions and millions of rows and thousands of columns during such a night. So you want to be able to zoom in on those things that are important. It can be scripted, so you have the result at the end of the batch jobs, so in the morning when you come into the office. These are some of the customers that we've been working with. You saw some concrete examples in one of the first slides already, yeah. A quick recap. So if you want to have your valuable applications, of course, those applications that you want to continue to work with for the coming years in the latest technology, natively, in the cloud, natively, then this is a potential way to get there. You solve your skills issue because a lot of people, of course, a lot of clients do not have natural skills anymore, or at least they are becoming a scarce resource, or IDMS. But also even JCL, we know plain COBOL sometimes is getting an issue. You have maximum return for minimal risk and effort because the risk is very well managed. There's a fixed price up front. You know exactly what's going to cost. Very short project duration because we really emphasize that we automate not only the conversion, but also the testing, which is an enormous help to keep the project duration short. As I've already said, fixed price. The project scope, which is often an issue, and because you have these moving parts, basically, the project scope is very, very clear. It's the user interface, the functionality, performance, everything is very clear what is expected upfront and what needs to be reached. There is no impact on the end users, and it's a very, very well-managed risk with guaranteed business continuity. And very important, it is the first step potentially on a journey to further modernization, because from that moment on, you are already in your new environment. You're natively in the cloud. You're natively using the latest IDEs and everything. So from there, you can further modernize without limits. Here's we have a lot of material available. You can go to our website and you will find a lot of guides and white papers and stuff, research papers. Here's one that with how to migrate to the cloud in 6 steps, but there's a lot available. So I invite you to contact us or to reach out if you have additional questions. This is my mail address also. Thank you for your attention. If there are any more questions, I think we have good in time, so we have some time left for questions. Thanks.
Now I'm audible. Yeah. Yeah. Thank you very much, Mario, for your presentation. Yeah, as Mario said, we still have a few minutes for the Q&A. So I would say let's start right in. I already have a few questions. So the first question that I have here is, how many of your customers these days go to Java or C versus COBOL these days?
That's a very, very interesting question indeed, because we've seen that evolving and changing over the last years, basically. Like I would almost say, like 3 years ago, somebody moving from procedural language to an object-oriented was rather exceptional. So there was the few. These days, when we start a project, I think 80% of our customers decide, to take the opportunity because they're making this investment, they're making these changes to go straight away to Java or C#. Yeah. and create basically one development team also. In the past, they often had the back-end and the front-end development teams, two different worlds, and people want to get out of that division also, if I may call it that way, and just have one development team with the same skills, the same tools and everything. Yeah.
Mm-hmm. Thank you very much. What would you say are the main benefits of Java or C? Speaking of the languages that we just mentioned.
The benefits is, of course, the skills. It's hard to find COBOL developers also on the market. And if you find them, they're very expensive. So everybody, that comes from school knows Java or C#. So, and also, as I mentioned already, you have one pool of people, also all the same skills, the same tools. So you can move them around from the back end to the front end, wherever you want to invest at that moment, and have a need for quick development. So that's a benefit you definitely have.
Speaking of COBOL, here's another question. COBOL is quite old as a language. Why would you say is it still present in these days in a lot of companies?
That's a very good question. I think because, as we all know the statistics that there's, I don't know, 500. It's an enormous amount of lines of COBOL still out there. Most of the main applications, the core applications of a lot of businesses, just still run on COBOL. And I think that's historically. The banks, insurance companies, government institutions start to automate in the 80s, 70s, 80s, last century basically, and they never took the opportunity to replace the applications there or to modernize them, and they always built additional things around it. So, and we're still stuck with it, if I may call it that way. It's still there, yeah. But now people are getting out of it. So for the first, it has been predicted a couple of times already, but now it's really happening. People are getting out of COBOL. That's a fact.
Okay, thank you very much. I have one more question at the moment. Of course, to the audience, if you have further thoughts or questions, please let us know. We still have 3 or 4 minutes for the Q&A, but let's come to the last question for now. That is, what is the most critical factor in a typical modernization project using the refactoring approach? Is it the planning, the testing, or the team that works on the project, or are there even other aspects that one needs to take into account?
Oh, that's a difficult question, I think. The most critical, I would say, it's the planning. I guess it's the planning. We have, yeah, it's the planning. We have a lot of experience in what needs to happen when, and people sometimes intuitively wants to do things different. So people, typically organizations, do this kind of projects maybe only once during a decade or even less, and they often have a hard time taking our advice when we call it that way. That we said, no, we understand that intuitively you want to do it this way, but believe us, it's not the right thing. So, for example, people want to do it piece by piece by piece by piece, and that's a recipe for failure. If you do it piece by piece, you have to do it, an entire LPAR or whatever in one go, or an entire application in one go, because otherwise you build all these temporary interfaces, you need to test them. So planning is key. Planning is key. And planning in the back of your mind, this is a different project than we have ever done before.